Before we dive into any code and actually use Redux, I want to take some time to talk about the issues that we're going to run into if we don't use Redux, if we continue to use component state. So instead of just diving right into the solution, let's go ahead and explore the problem a little bit. So there's going to be two parts to this video. First up, we're going to explore the issues we'll run into with component state in complex applications. Then we'll explore how Redux can solve those issues, allowing us to build out complex and real-world applications. Now, these two tools, component state and Redux, they both aim to solve the same problem, which is to manage the state for your application. So state is data that changes, which means that we need a way to actually change the data. For component state, it was this .set state, and we need a way to get the data out of that state container. We need a way to render it to the screen. And for components, we just used this .state whatever the value was. So they both solve the same problem, tracking changing data. Let's go ahead and look at the differences between the two, and we're going to kick things off by talking about a simple application and a complex app. I'm going to categorize the app we created previously in Decision App as a simple one, and I'm going to categorize the one we're about to build, the Expensify app, as a complex one. So the component tree for Indecision App started off with the Indecision App component. We then had some other components down below. We had options, we had add option, and we had a few others, but for now, we're going to focus on just a subset of the component tree. So down below that, I am going to include option as well. So let's just explore these four components. Now, where did the state live? Well, the state lived up here inside of Indecision App. This was a class-based component that used component state to keep track of the changing data for our app, which was just a list of strings. This made it really easy to render everything to the screen and to respond to user interaction. We passed props from Indecision App down to its children. For add option, we passed a method it could call in order to add a new item. Options needed the array of current options, so we passed that down, and option needed the individual item, and that got passed down as well. This prop tree was possible because all of our components are connected. There is a direct connection between every single thing. So all we do is we store the state up here, and it can pass the necessary items down, making this simple application work. If I want to add a new option, I just submit the form. I pass the form data up. This changes the state up here, causing it to re-render, causing the new options list to show. Now, this is great for simple applications. We're able to store component state here and get everything working as expected. But this is not what we have. In our new application, we do not have a single tree view where everything is interconnected. What we really have are two tree views. So we have an add expense page and we have an expense dashboard page. There is no parent component that renders both of these. Instead, both of these are rendered by React Router, and they have children of their own. So for add expense page, we're going to add a form. We're going to have the add expense form sitting right inside of there. For the expense dashboard page, we're going to have the list of expenses, and we're going to have the individual expense as well. Now, in this situation, how do we structure the data? There is no one parent component where we can store that component state. There is no connection between every single component. So if we wanted to change the state, for example, if we added a new expense, where does this data go? Do we try to store the state up here? In which case, how do we get it over here? Do we try to store it over here, or maybe even down below? Exactly where does the state live? So this is the first problem we're going to run into with component state. For simple apps, it's very clear to figure out where it should live. For complex apps, it's not quite so clear because there isn't just one parent that needs to keep track of all the data. So there's the first issue we're going to run into. When we have multiple component trees, sharing data isn't as easy as it might sound, and there really is no way to get this done with component state. The other issue that we're going to explore is that the components that we're creating aren't really reusable. To explore what I'm talking about, we're going to look at the Indecision app once again. So right here, we have the Indecision app component, and we had some children, option, modal, action, and header. And for this example, we're just going to explore this particular subset of the components we created, and let's just focus in on action. So how did action work? Action rendered our really big button, and it needed two props in order to work. It needed handle pick and has options. Has options was the Boolean letting it know whether the button should be enabled or disabled, and handle pick was a function. It could call that function to tell Indecision app to actually pick an item and show it in the modal. Now, what if we wanted to reuse action? So let's say we have that one big button front and center, and we also wanted to toss a button up in the header, maybe in the top right-hand corner, a much smaller button. How would we get that done? Well, we could just take the action component and we could use it inside of header. The problem is that this is not going to work. Why not? Because the action component is going to say, hey, I actually need props. You can't just use me anywhere. So the action component is actually really closely bound to indecision app. So we have this illusion of reusability because we've broken things into components, but in reality, they're all very closely tied together. If I did want action to live inside of header, I would have to tie things even closer together by passing the props from indecision app down to header. Header really should not know these exist because it doesn't need to use them. And then header passes those down into action. So now we have even more spaghetti code where all of our components are so closely bound that they really can't be reused. What we need is a way for components to be able to interact with the application state, both getting and setting values, without having to manually pass props down the entire component tree. In this case, it's 1 or 2 levels deep, but you could imagine a situation where we have 3 or 4 levels deep and we have to pass the thing all the way through the component tree until it gets to its final destination. It would be much nicer if each component could describe what it needs from the state and what it needs to be able to change on the state. And that's exactly what we're going to end up doing with Expensify. So we're going to have the exact same tree we saw before. We have add expense, we have expenses, and we have expense. But now let's say we want to reuse add expense. We want to show it on the add expense page, but maybe we also want to show it as part of this page. So in order for this to work, we have to come up with a situation where we can render both of these without having to pass any props down from the parent. So add expense is going to get no props from add expense page, and add expense here is going to get no props from the expense dashboard page. Instead, they're both going to interact with this global Redux state container. So that's going to allow them to either get values like expenses or set values like add expense, and they're going to be truly reusable. The add expense component will be able to say, I can go anywhere, and they will be able to go anywhere. Without any clear prop binding, we can put them anywhere in our tree. We're going to figure out later how exactly they're going to be able to fetch and change the application state, but for now, we just need to know that this is where we're trying to get to. So what are the questions that we need answers to? First up, where do I store my app state in a complex React app? And how do I create components that are actually reusable? Well, the answer to both of those questions is to use Redux. So let's go ahead and explore exactly what this is going to look like. Let's kick things off by bringing the entire component tree into view. You notice that there are no props getting passed here, here, or here, but there is one getting passed from expenses to expense. This is much like how we passed an individual prop from options to option. There is nothing wrong with props. We are going to continue to use props throughout the entire course. It is a perfectly valid way of communicating data between parent and child. And when you're passing data, a prop, down to a child, and the child actually uses it in a meaningful way, that's a great use case. Continue to use props in those cases. The only time we really want to avoid props is when we're passing props down this long chain of components just to get it to the last one in the chain. The components in between aren't actually using the value, they're just passing it along. In that case, we probably want to avoid using props and we should use something like Redux instead. Otherwise, we have exactly what we saw in the last video where we had this very tight binding between the components in our application. So what exactly is Redux? Redux is a state container, which is exactly what our class-based components are. There is an object, we can change the object, we can read from the object, nothing fancy there. We create a Redux store, and it's just an object, like this.state was an object inside of our components. On the store, you can see we have a single piece of state we're tracking. We have an expenses array. The array would probably start off as an empty array like our options array did. And then as we added expenses, we would add things into the array. In this case, it's going to be an object. So each object in the expenses array is a new expense. And we're creating objects because we need to store multiple things about the expense. We need the ID, a unique identifier. We need the description, some sort of string definition for what the expense was. In this case, it was my rent. And we need to store the amount, which is going to be a number, and we're going to store that in cents. So this is the exact store value, and you could see how we could do this with regular component state. We would set up this.state equal to an object, would provide a single thing, expenses, setting it equal to an empty array, and then we would use this.setState to add items in. So with Redux Store, we're going to be able to do both of those things. We're going to be able to read data off of the store and change the data in the store. But the cool thing is that the individual components, they're going to be able to determine how they want to do those things. So each component can say, hey, I need some data from the store. And each component can say, hey, I need to be able to change some data on the store. So for add expense, it might say, I need the ability to add an expense to the store. And the Redux store would say, sure, go ahead and call this function whenever you actually want to add an expense, just pass along the necessary data. This means that add expense can get used anywhere. It's not getting anything directly from the parent. So over here, we can also get the ability to add something to the store. Now, the other components inside of our app, they're also going to need to be able to work with the store in one way or another, either reading or writing data. So the expenses component, for example, is going to say, hey, I need all of the current expenses. This is the array. And the store is going to respond, giving that to the expenses component so it can actually render the list. Now, the individual item gets passed down, but the individual component might still want to do something with the store. Maybe we have a remove button like we did previously, and the expense component wants to be able to remove itself. So we might have something like, hey, I need the ability to remove an expense from the store, and the Redux store would say, sure, call this function with the ID whenever you're ready to remove an expense, and I'll take care of that for you. So as you can see here, our components aren't communicating between each other so much as the individual components are communicating with the store. This creates components that are very reusable. So add expense over here can get the exact same stuff that add expense over here has. It can say, hey, I need the ability to add expenses to the store, and then Redux would respond with the function allowing add expense to actually add an item. That's where we're going to stop for this one. I know this was a long one and it was a slide-based video. I really do try to avoid these, but Redux is a very complex topic. When I filmed the first edition of this course, Redux was one of the topics that students said I went way too fast on, and they really didn't grasp exactly why it was useful. So the goal of this video wasn't to learn a single thing about Redux. The goal of this video was to learn about the shortcomings of using component state, and we learned about two. One, in complex apps, there's no clear parent component where we can store that state. Here, React Router renders two tree views. How exactly do these two separate trees communicate with component state? There's no way to get that done. The other problem is that when we use component state, our components end up communicating a lot. Now, this isn't inherently bad, but when we do it a lot, we create components that are not reusable because they need so many things from the parent, which means they can't just be dropped anywhere because the parent might not have the things they need. What's the solution to both of those problems? The solution is Redux. With Redux, each component can define two things: what data it needs and what data it needs to be able to change. In the rest of the section, we're going to explore exactly how we do that. We're going to start off by exploring Redux in isolation, then we're going to wire it up to work with our React components, and by the end, we're going to see exactly what advantages this tool is going to give us. I am very excited to dive into this section and explore exactly what Redux is and how it works. So let's go ahead and dive into the next video where we're actually going to get this installed and set up. Stay tuned. I'll see you then.